A quadratic equation in standard form will be in the form ax squared plus bx plus c equals 0. Let's say that we want to solve a quadratic equation that reads x squared plus 3 equals negative 4x. As we can see, it's not exactly in the form above. One of the things that makes this type of equation difficult to solve is we have multiple x's going on in the equation. But we do have methods for solving it. So first I'm going to try to get it into the form above and get all the terms onto one side. I'm going to add the 4x to both sides so that I basically bring the 4x over to the left. And we'll leave behind just a 0 on the right. The reason why we have a 0 is the negative 4x and the 4x, they cancel. Now we can see that we have the same form as above, and so we can easily identify the a, b, and c for our quadratic. The a is the number attached to the x squared, and since there isn't one there, it's assumed to be a 1. Okay, so a is 1 here. The constant that's attached to the x will be the b, and then the constant that's alone will be the c. Alright, so we have a equals 1, b equals 4, and c equals 3. One of the methods we have for solving quadratic equations like these is to factor it, actually. So let's see if we can factor this, and we'll get x and x. Our lasts have to multiply to 3, so let's try x plus 3, x plus 1. Now we can reason out a couple of solutions to this equation. The way we reason it out is by using a thing called the zero factor law. The zero factor law says that whenever two things are being multiplied and the result is 0, then logically it must be that either the one factor is 0 or the other is. So either a is 0 or b is 0. That's the only way we could get a product of 0, is if one of those or both were 0. So to apply this to our problem, we'll say that either x plus 3 equals 0 or x plus 1 equals 0. One of these things must be 0, either this one or that one, or both. Now we'd want to solve those equations independently here and see what solutions we get. So let's subtract 3 here to reveal that x equals negative 3 is one solution to the equation. And we'll subtract 1 here to reveal that x equals negative 1 is another solution. So we actually have two solutions to this quadratic equation. And that's common for quadratics. You don't always have to have two solutions though. You might have one solution or even none. Now we should look at what our quadratic equation looks like to see if we can graphically understand why these are solutions to it. Now in order to graph our quadratic, what we want to do is we want to set the stuff on the left here equal to y. So we can do this. Plot y equals 1x squared plus 4x plus 3. I'm gonna go to desmos.com and plot this. Alright, let's type in our quadratic y equals x squared plus 4x plus 3. It's a parabolic function. And to graphically understand the meaning of the solutions here, we see that we have a x equals negative 3 as an intercept and a x equals negative 1 as another intercept. It's called the roots of the quadratic equation. Okay, now what other methods do we have for solving a quadratic equation like this? Well, we can use a thing called the quadratic formula. So the quadratic formula says if you have an equation y equals ax squared plus bx plus c, and you want to find the roots of that, then you'd want to set the y equal to 0. So in other words, we want to know when this parabola touches the x-axis. And for our equation, we saw that it touched twice on the left-hand side of the origin. It touched here and here. Those are known as the roots. And there are 2 of them. To find them using the quadratic formula, we'll use this. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's the quadratic formula. There's a lot to it, and as you can see, it has a plus or minus, so there is a possibility of getting 2 answers out of this formula. Now, if you recall from our quadratic, a is 1, b is 4, and c is 3. Those are going to be the things that we want to plug into it. Alright, so let's go ahead and plug in. And what I do to get started with something like this is to just replace every variable with open parentheses. And this is going to be where I'm going to plug things in. But I copy the entire formula exactly as it appears above. And now I'm ready to plug the different things in. So for b, we have to plug in a 4. And we'll do that here as well. Over here we're going to want a, which is 1, and then c, which is 3. Down below we'll want a, which is 1. And now all I have to do is just correctly simplify that. For many problems you can plug it into a calculator to get an answer. Let's do it by hand though here. So we'll get negative 4 plus or minus the square root of 4 times 4 is 16, minus 4 times 1 times 3 is 12, and then we'll divide by 2. Try to simplify it more. 16 minus 12 is going to be 4, and we'll have that. Let's take the square root of 4, which is 2. And since both of these are being divided by the same denominator, we can actually divide and get negative 2 plus or minus 1. Alright, at this point you may wish to break it up into two separate statements, -2 plus 1, or x equals -2 minus 1. And we'll get our final results, which match what we had found previously using the factoring method.